All right, so we left off somewhere around here. Whoops, that's the wrong thing. Fail. That's better. Okay. What would you do to solve this? Okay. So you'd have x is less than or equal to x minus 5. Then what? Okay. What's x minus x? 0. 0 is less than or equal to negative 5. That is not true. Guess what that means? There is no solution. Or if you want, you can write the symbol for the empty set. I mean, if you think about it, if I take a number and add 7, how can that be less than the same number plus 2? It doesn't make any sense. All right. Yay. Let's talk about compound inequalities. If you recall, a compound inequality is basically two inequalities squished in to make one inequality. How do you solve this? All right, so I need to get x by itself in the middle, so I'm going to start by subtracting 1 everywhere. Then what? All right. So that would give me negative 2 is less than x is less than or equal to 1. How would I write that as my final answer? Indeed. Oh, there's someone at the door. Pause. We're in good shape? All right. So, let's look at absolute value inequalities. Man, I can't spell this morning. Riding the struggle bus again. I mean, there's varying degrees of the struggle bus. You could be riding the struggle bus. You could be driving the struggle bus. You could be being run over by the struggle bus. Some days you're the windshield, and some days you're the bus. All right. So, if you recall from last semester, if the absolute value of u is less than c, that means that u is between negative c and C. If the absolute value of U is greater than C, that means that either U is greater than C or U is less than negative C. Now, for this one, we use AND, or an intersection. For this one, we use or a union. And I don't know if you remember or not, but at some point I told you less than and greater. Sound familiar? Somewhat. All right. Now, does anybody need more time on the screen? We're good? All right. So, let's say that the absolute value of x minus 4 is less than 3. There are two ways you can do this. Since the absolute value is isolated, you can do this like we did before, right? And you can say x minus 4 is less than 3. What's the other one? Is greater than negative 3. And what word do we use in here? And or. And, because this was less than, right? So then you solve this. I don't think it takes a genius to figure out that you got to add 4. So x is less than 7, and x is greater than 1. If I were to draw that on a number line, there's 1, there's 7. This one goes this way, this one goes this way. And with and, that means you want the part that overlaps. So that would be from 1 to 7. Now, the following thing works with and, it does not work with or. But if you remember on the last screen, I made it into a compound inequality. So if you don't want to do it like this, you can just remember that if it's less than, you can make it into this. Then you can solve it the way we did that other one. You add 4 to everything. And you get 1 is less than x is less than 7. And then most of you could probably go straight from there to there. I don't care which way you do that as long as you do it accurately. But again, you can only make that compound inequality if there's a less than. If there's a greater than, you have to do it separate with an or. Understood? Very well, let's continue. All right. Thoughts? Yeah, what you need to do is you need to isolate your absolute value, because if you don't isolate your absolute value, half your answer is going to be wrong. So if I subtract 7 from both sides, I get negative 2, absolute value of 3x plus 5 is greater than or equal to negative 20. Then what? Okay. Absolute value of 3x plus 5. This would be 10, right? What goes between them? Why are we flipping the sign? Be divided by a negative. Indeed. Which inequality symbol do I base whether I use and or off of? Do I use this one up here? I guess for the people on the video, I should probably circle this or something. Yeah, that's yellow. So do I use this one right here, or do I use that one right there? Say what? Yeah, the last one, because you want to use the one once the inequality's been isolated. So since this is a less than, we can work it like the other problem. Do you want to do it as a compound, or do you want to do it as two separate with an and? Okay. So, what would they be? Anytime you're ready. I'll give you the negative 10. You got to flip the inequality. All right. The next part should be fairly straightforward. Subtract 5. 3x is less than or equal to 5. I forgot the word and. And 3x is greater than or equal to negative 15. Divide by 3. So let's see, x is less than or equal to 5/3, and x is greater than or equal to negative 5. There's negative 5. 5/3 can go there. That one goes that way. That one goes that way. What's our answer? Do more than one of us understand how to generate that from the graph? Because if you don't, now's the time. Okay. I'll bet I can't squeeze the last example in, so we'll have to let